Welcome to part 3 video of chapter 2 polynomials. In the part 1 video we have discussed that for a linear polynomial ax plus b, the 0 is given by minus b by a, that is negative the constant by coefficient of x. Now let's see if there is similar relationship between the zeros and coefficients of a quadratic as well as a cubic polynomial. Let's take an example. P of x is equal to 3x square plus 5x minus 2. Now, how do we factorize this? So let's factorize this by the splitting the middle term method. For that, you have to find two numbers such that the sum of the two numbers is 5x and the product is minus 6x square. How minus 6? Minus 2 into 3. Now, what are those two numbers? 6 and minus 1. How? 6 plus minus 1 is 5 and 6 into minus 1 is minus 6. So we can write this as 3x square plus 6x minus 1x minus 2. Taking the common terms out from this, you get 3x into x plus 2, and taking x plus 2 common from this, you get minus 1. Right? Now you can write this as 3x minus 1 into x plus 2. These two are the factors of the given quadratic polynomial. Now how do we find the zeros? For that you have to equate both of these factors to 0. That is 3x minus 1 is equal to 0 and x plus 2 is equal to 0. So from this you get 3x is equal to 1 and x is equal to 1 by 3. And here x is equal to minus 2. So 1 by 3 and minus 2 are the zeros of this quadratic polynomial. If you require any further examples or further explanation regarding splitting the middle term, do check our class 9 polynomials video. So we have found that 1 by 3 and minus 2 are the zeros of the given quadratic polynomial. Now let's find the sum of these zeros. That is 1 by 3 plus minus 2. So minus 2 means minus 2 by 1. So you can write it as 1 plus minus 6 by 3. How? 1 into 1, 1 plus minus 2 into 3 is minus 6 by 3. 3 into 1, 3, which is equal to 1 minus 6 is minus 5 by 3. And what is the product of zeros? That is 1 by 3 into minus 2, which is equal to minus 2 by 3. Now, if you compare the sum of the zeros, that is minus 5 by 3, to our given question, that is 3x square plus 5x minus 2, you can see that this is equal to negative the coefficient of x by what is 3? The coefficient of x square. Is that clear? 5 is our coefficient of x and 3 is the coefficient of x square. And if you compare the product of the zeros to the question, you can see that minus 2 is our constant by 3 is the coefficient of x square. So, in general, you can say that if alpha and beta are zeros of any quadratic polynomial, alpha and beta are Greek terms. So, if alpha and beta are the zeros of any given quadratic polynomial, then you can say that alpha plus beta, that is sum of zeros, is given by minus b by a, and product of zeros, that is alpha into beta, is given by c by a. How? You know that the general formula for a quadratic polynomial is ax square plus bx plus c. So b is the coefficient of x and a is the coefficient of x square. C is the constant term by a is the coefficient of x square. That's what we have proved before. Similarly, you can prove that for any cubic polynomial, ax cube plus bx square plus cx plus d, if alpha, beta and gamma are the three zeros, again gamma is also a Greek letter, if these three are the zeros, you can say that the sum of the zeros alpha plus beta plus gamma is equal to minus b by a. What is b? The coefficient of x square. And what is a? The coefficient of x cube. Again, alpha beta plus beta gamma plus alpha gamma is equal to c by a. What is c? The coefficient of x, by a is coefficient of x cube. Now the product of the zeros, that is alpha, beta, gamma, is equal to minus d by a. Now let's discuss some of the exercise questions. Exercise 2.2, question number 1. Find the zeros of the quadratic polynomials and verify the relationship between the zeros and the coefficients. Question number 1, x square minus 2x minus 8. Let's factorize this by splitting the middle term. You have to find two numbers such that the sum is minus 2 and the product is minus 8. That is 1 into minus 8. So what are the two numbers? Minus 4 and 2. How? Minus 4 plus 2 is minus 2 and minus 4 into 2 is minus 8. That's our condition. So you can write this question as x square minus 4x plus 2x minus 8. Taking the common terms out, from these two you can take x common. So you write x minus 4. Again, taking x minus 4 common from these two terms, you get x minus 4. What is remaining? Plus 2, right? So you can write this as x plus 2 into x minus 4. Now how do we find the zeros? Equate both of it to 0. So x plus 2 is equal to 0, giving x is equal to minus 2, and x minus 4 is equal to 0, giving x is equal to 4. So minus 2 and 4 are the zeros of this given quadratic polynomial. The second part of the question is to verify the relationship between the zeros and the coefficients, right? We know that alpha plus beta is equal to minus b by a and alpha into beta is equal to c by a. This is what we have to verify. Now let's find the sum of the zeros in this case, that is minus 2 plus 4 is equal to 2. This is our question. What is minus b in this? Minus b by a is equal to negative of minus 2 by what is a? 1, which is equal to 2. It's same as what we have got. Now, what is the product of the zeros? Minus 2 into 4, which is equal to minus 8. And what is c by a is equal to, what is c? Minus 8 by 1. It is same as what we have got. So we have verified the relationship between the zeros and the coefficients. Next, question number 4, 4u square plus 8u. Here you don't have to do splitting the middle term. Instead, you can take the common terms out. So taking common terms out, you get 4u into u plus 2. So 4u into u is 4u square plus 4u into 2 is 8u, right? Now, to find the zeros, you have to equate both of it to zeros. That is 4u is equal to 0, giving u is equal to 0. U plus 2 is equal to 0, giving u is equal to minus 2. So 0 and minus 2 are the two zeros of the given quadratic polynomial. Now sum of the zeros. 0 plus minus 2 is equal to minus 2. And what is our minus b by a from this question? We know that this is of the format ax square plus bx plus c. So what is b from this? 8, right? So what is minus b? Negative 8 by what is a? 4. So you get 8 by 4 is equal to minus 2. So it is same as the sum of the zeros which we got. Now what is the product of the zeros? 0 into minus 2 is 0. And what is c by a? There is no c in this term. There is no constant, right? So you get 0 by what is a? 4, which is again equal to 0. Question number 5. T square minus 15. You know that you can write 15 as root 15 the whole square. It's the same. So you can write this question as t square minus root 15 the whole square. This is of the format a square minus b square, which is equal to a minus b into a plus b, right? So you can write our question as t minus root 15 into t plus root 15. Now these two are the factors of the given question. And how do we find the zeros? Equate both of it to 0. So t minus root 15 is equal to 0, giving t is equal to root 15. And t plus root 15 is equal to 0, giving t is equal to minus root 15. So plus root 15 and minus root 15 are the zeros of this given quadratic polynomial. Now, what is the sum of the zeros? Plus root 15 minus root 15 giving 0. And what is minus b by a in this? Minus b by a is equal to, there is no b term, right? So it is 0. And what is root 15 into negative root 15? Giving minus 15. And what is our c by a in this? Minus 15 by 1. 1 is the a, there is no b term, and minus 15 is our c. So we have verified the relationship between the zeros as well as the coefficients of the given question. Question number 2. Find a quadratic polynomial each with the given numbers as the sum and the product of its zeros respectively. Now in that question number 1, 1 by 4 comma minus 1, that is sum of the zeros alpha plus beta is equal to 1 by 4. What is alpha plus beta? Minus b by a. And alpha into beta, which is equal to c by a, is given as minus 1. So from this you can see that what is b? If minus b is 1, what is b? Minus 1. And what is a? 4. And from this we know that a is equal to 4. So what is c? If a is 4, c is equal to minus 1 into 4, which is minus 4. So c is equal to minus 4. So we have got what is a, b and c. Now we can find the quadratic polynomial that fits this, right? So 4x square, that is a into x square, minus 1x minus 4. This is one quadratic equation that fits the given condition. Now, second question. Root 2 and 1 by 3. Root 2 is the sum of the zeros and 1 by 3 is the product of zeros. So, alpha plus beta, which is equal to minus b by a, is equal to root 2. And alpha into beta, which is equal to c by a, is equal to 1 by 3. So, from this we can find that c is equal to 1 and a is equal to 3, right? So in the first given equation, minus b by a is equal to root 2. So what is minus b? If a is 3, 3 root 2. So what is b? Minus 3 root 2. Now c is equal to 1, a is equal to 3 and b is equal to minus 3 root 2. So what is the equation? 3x square minus 3 root 2x plus 1. This is one equation that fits the given condition, and any multiple of this would also fit into the same condition, that is k times 3x square minus 3 root 2x plus 1 will also have sum of the zeros as root 2 and the product of the zeros as 1 by 3. Here in the first case the value of k is 1. Now you can replace it by 2. You get 2 times 3x square minus 3 root 2x plus 1. It becomes 6x square minus 6 root 2x plus 2. So in this case, what is b by a? Minus b by a is what? Minus of 6 root 2 by 6. That is same as minus of minus is there, right? So minus of minus gets cancelled. The answer is root 2. And what is c by a? One by 3, right? That's the same question that is given to us. So any multiple of this would fit into the conditions that's given to us. Question number 3. 0 is the sum of the zeros and root 5 is the product of the zeros. So alpha plus beta is equal to minus b by a is equal to 0. And alpha into beta is equal to c by a is equal to root 5. Root 5 means root 5 by 1. So c is equal to root 5 and a is equal to 1. And from this, if a is equal to 1 and minus b by a is equal to 0, what is b? 0. So what will be our equation? 1x square minus 0x plus root 5, that is plus 0x, okay? So x square plus root 5. This is our equation. Similarly, you can solve the rest of the questions in the exercise. And the next topic is division algorithm for polynomials. It will be discussed in the part 4 video. If you have found this video beneficial, do not forget to like, share and subscribe to our channel and keep watching our channel for more videos.